Good morning, everyone. So today we are going to talk about volume, okay? So we have talked about area, we've talked about surface area. Those two were dealing with, two-dimensional shapes. Even surface area that dealt with three-dimensional shapes, what it was actually talking about was the surface of your three-dimensional shape, in case of this cube, which is just a square. That's still a 2D shape. So in essence, we were still talking about the 2D shapes within the 3D shapes. So that's all that area and surface area was. Well, now we're moving into volume, which deals with three-dimensional shapes and three-dimensional shapes only. So area talks about how much space does it take, how much space does an object take. So, if I have a square, how much space does that take? And surface area is talking about, if I were to lay a blanket over my three-dimensional shape, how much of that blanket am I going to need to cover the entire surface? So on that one, you're talking about the whole thing, right? But with volume, what we're really talking about here is we're talking about how much does it take to fill up my object. So if I were to put little itty bitty tiny cubes in here, how many cubes would it take to completely fill my object up? So that's what volume's talking about, okay? So just like with area, when we talked about area with rectangles and squares, volume also has two different um, formulas that you can use, and they in essence become the same formula. They just look different because remember, rectangles have three different side lengths. Rectangular prisms had three different side lengths, so we need three different variables to represent those, which in this case will be length, width, and height, whereas a cube only has one side length, and so that's our side. So if you remember from our area of a rectangle, our area of a rectangle is area equals length times width. So what do you think volume of a rectangle would be? Volume of a rectangle is going to be length times width times height. Hopefully you guessed that. Length times width times height. And in variable form, that's just V equals L times W times H. Okay, so for this example, you have your L of 22, your width of 1.5, and your height of 4. So you would just plug those into your formula. So instead of writing L, we would write 22. Instead of writing W, we would write 1.5. And instead of writing height, we would write 4. Multiply them all together, and you get a final answer of 132. So this rectangular prism, it takes 132 meters cubic blocks to fill it up. Okay, so now that we're in volume, we've switched our units from squared to cubic. Okay, same thing with our cube. Our actual formula for our cube is going to be volume equals, if I can write an equal sign, side cubed. Okay, remember this is a cube, therefore we have to cubic, which is going to be the same as V equals S times S times S. So if you look at that formula, V equals S times S times S, it looks very similar to V equals length times width times height. You are still multiplying three numbers together. It just so happens that in a cube, it's the same three numbers. So when you look at it, our side length is 2.5. Well, how can I take that fraction? Because who really likes working with fractions? Not me. How can I take that fraction and change it to a decimal? Well, say it. What is it? It's 2.5. Well, how do you write 2.5 as a decimal? 2.5. 2.5. Okay, so now that's easy peasy lemon squeezy. We can just plug that into our calculator. No big deal. So our side length is 2.5. So our formula will then be V equals 2.5 times 2.5 times 2.5. I'm still multiplying three numbers together. They just so happen to all be the same number. So when you put that into your calculator, 2.5 times 2.5 times 2.5, you get a final answer of 15.625